Okay, let's get focused here. All right, so here's what you're looking at. Let's multi-step inequalities. And technically, we're at the point where we are just combining a whole bunch of little lessons that you should know how to do it by now, because you know how to solve multi-step equations, right? You know how to solve inequalities. The one little trick difference is when you multiply or divide by a negative, you have to switch the sign. So, I mean, technically, this could technically be a lesson where I say, all right, go ahead and just do the homework. You don't really need any notes, but we're going to still go over that, though. All right. So, just like if that were a two-step equation, instead of an equal sign, it has an inequality sign. You're still going to, because I am going to teach you one little trick here today. So, everybody understand why I add 7? Okay, the opposite of subtracting is adding. So then 3x is going to be less than 15. Divide both sides by 3 because it's being multiplied. I didn't divide by a negative, so that stays less than. And if you were to be asked to graph this, it would be less than, right? Don't color it in because it cannot include 5 in its solution. And then all the values that x could be are 4, 3, 2, and ... Okay? No, I mean, there may be, as long as you're comfortable with this and you know what you're doing, I don't want you to not have enough practice, but I'm just doing that just to kind of remind you. Okay. Yeah.
Doesn't the arrow always point?
Well, I am so glad that you asked that. He says, doesn't the arrow always point where this sign is basically pointing? And do you remember, did we talk about this Friday? Okay. That's the case only when what? Good, yes, when the variable's on the left. If I were to take this and make this 5 is less than x, okay, let's listen to that and apply some logic. If 5 is less than x, that must mean that x is greater than 5. So in this case, the x is not on the left. I'm not going to make my line go this way. At that point, I have a choice. I either have to read it from the x and say x is greater than 5, or I choose to turn it around and put it so the x is on the left. And if I do that, then x then is greater than 5. So that's one time where it's not going to go the direction that it's pointing, okay? I'm glad you asked. All right, so I'm going to show you 2 shortcut rules today because you're going to want to use them. So if I have like x or 5/10 x minus 1.2 is less than or equal to 4.8, okay? Yeah, I know. I already heard a few noises. You look at that. It doesn't look fun to you, okay? It's got decimals. And the 2 things we don't like to have to deal with in equations or inequalities are decimals and fractions, right? So if you had some like magic method to get rid of all the decimals and all the fractions, would you use it? Probably. So that's what I'm going to get you today. We're going to talk about how to clear the decimals and fractions. So if you don't like them, get rid of them. And it's a very easy step to follow. So I want you to think about this. My daughter's learning this lesson right now in 5th grade, and it has to do with multiplying and dividing by tens or powers of tens. If you multiply by 100, it moves 2 to the right. If you divide by 100, it moves to the left. So could I move this decimal and just kind of keep bumping it down until it's gone? What do I mean by gone? Where do I want it? At the end, right? So what would I need to do to get this 50 cents and turn it into $5? I would need to multiply by 10, right? If I took this and bumped it here and the $1.20 became 12, then we would be good. And what about the 480? Became 48. So really what I just did with that whole equation is multiply it by 10. Multiplying it by 100 would move it 2 places. And the way I help her remember that is it goes by however many zeros it has. 10 has 1 0. It bumps it 1 place. 100 has 2 zeros, so it would bump it 2 places. So my whole new equation, when I basically distribute that, is 5x minus 12 is less than or equal to 48. So much easier, isn't it? Okay, so now you don't have to deal with decimals, and I know you have a calculator, and it wouldn't be so bad anyway, but this way it just goes a little quicker. So I'd add 12, and then I would just finish it from here. division property of equality, x is less than or equal to 12. Okay, easy enough? Okay, that's just the basic step. What would I do if I had 2.4 is greater than 1.75 minus 0.6x? What do you notice is a little bit different about this one than the first one? Here they all went out to the 10th place, but not so this one has one. Yeah, it goes to the 100th place. So would multiplying this equation by 10 be enough? It would make this 24. It would make this 6, but it would only make this 17.5. So multiplying it by 10 isn't going to be enough. I need to do what? Yes, I need to multiply the whole thing by 100, which brings up a question about what do I do if it only has a 10th place? Well, you know what to do, Sophia. Go ahead. Yeah, just add a 0. So when I multiply this and move it and I run out, I just add an extra one. This is going to keep it 175 here, and this is going to make this what? 6dx, okay? We're not going to solve it. We're just going to go from there. Okay, so basically what you are doing is you are finding the LCM, least common multiple, because 10 is the LCM of those, and kind of shifting that decimal until it kind of drops right off the end there. So from now on, when you see a decimal in an equation, you have the option of getting rid of it or just keeping it there and using a calculator. Would you get the same answer? Yeah, you would, okay? Clearing the fraction is awesome because I know people do not like working with fractions. So let's talk about how to do that one. If I have 2/3 x minus 5/6 is less than or equal to 1/2. You could solve it the good old traditional way and add 5/6 to both sides and add 5/6 to 1/2 and then add that, and then we wouldn't divide by 2/3, we'd multiply by the reciprocal and so on. Or you just get rid of them and turn them all into whole numbers. This one requires a little more thought. What would I multiply? Because both have to do with multiplying the whole equation. It has nothing to do with decimals. What number would need to go right here that when I distribute it in, the 3, because basically think about this. If the 3 was gone, and the 6 was gone, and the 2 was gone, it wouldn't be fractions. I just need those denominators gone. So what should I do, Will?
Multiply by 6.
Good. He says multiply by 6, and that's absolutely right. Where did he come up with that? Because that is the least common, or the common multiple, which is the common denominator, right? You know how when you add fractions, 6, 3, and 2, common denominator is 6. So watch what that does. It means I'm going to take 6 and multiply it by 2/3. And when I do that, 3 goes into 6, which is why I put it there. But don't forget to multiply this 2 by the other 2, and that leaves you with, okay, then you are going to do the 6 times the negative 5/6. And the 6's are going to totally cancel, and what's left? And what is 6 times 1/2? 2 totally goes into this, which is, ta-da, all gone. Easy enough? What's that? If they all don't go into 6, we're going to do one next. We'll do another one. So now all I would do is just finish up and solve it that way. And what I mean by LCM of 2, 3, and 6 is if I list all the multiples of these numbers, the LCM is the lowest one that they all have in common. Remember doing that in like 4th grade or 5th grade? Okay, so Blake had a good question. What if they all don't go into 6? So let's take 3/5 x less than 1/2 minus 8. I want you to just pretend like if you had to add those, what would your LCM, what would your common denominator be for 5 and 2? 10. So I'm going to multiply this whole equation by 10. It has nothing to do with the powers of 10 for decimals. It was just a coincidence. So when I do this and distribute it through, you can almost kind of do it in your head. I did it off on the side last time. 5 fits into 10 twice, and 2 times 3x is 6x. Half of 10 is 5. And then I want you to be very careful because the most common mistake kids will make when they're clearing a fraction is if there's a whole number, they'll forget to distribute the 10 to that too. So I can't just bring that down and make it minus 8. It has to be what? 80. Negative 80. Okay? Because you can't distribute to these two but not this other one. Okay? And then solve it from there. Good on that? Okay, so let's try this one. You can grab it. I'll have it there. 14x plus 5 is less than 7 times 2x minus 3. All right off the bat, you're going to recognize something. Go ahead, Bill.
For that other one,
Yeah.
that we just did,
Uh-huh.
could we make the parentheses just like around the 3/5 x is less than 1/2 and leave the...
No, because you can't. It's kind of like saying this. He wants to know, could you put the parenthesis here? No, because you need to multiply. Otherwise, it's not going to be an equivalent expression. If you would have kept that 8 and solved it, it would give you a totally different answer than it would have been up there. So yeah, it's always going to be around the whole thing. Good question. So when I look at this, I see 14x plus 5 is less than 14x minus 21. And if this was an equation and it had 14x plus 5 equals 14x minus 21, I know that's not true because when our 14x's cancel, 5 does not equal negative 21, and we would say false, right? Okay? Now, I know you're looking at this and you're thinking, I'm going to say false right away. And in this particular example, it is, because if I just canceled out those 14x's, which I guess technically we should do it this way, and that's why they cancel, what are you left with? 5 is less than negative 21. And is 5 less than negative 21? No, it's not, which is false, but we don't really need to write false because false leads us to tell us that what is our solution? Yeah, there is none. So we would say a no solution. Okay? Now, I want to ask you, though, to be careful because what if I just took this and flip-flopped it around? And when I distributed and I got 14x minus 21 is less than 14x plus 5, I'm telling you right now that we used to stop right there and be able to call it at that point, right? You can't do that anymore. Because what happens when I cancel the variables out this time? I get negative 21 is less than 5. And is that true? Yes, it is true. So in this case, I would then write either my all real numbers or infinitely many or whatever it is you want to write. But if I would have stopped at this point, you would have been wrong, correct? Because you would have said false. So when you're dealing with inequalities, you got to keep going. Or at that point, just picture, if this was gone and this was gone, is what's left true? Could you kind of see it buried in there? Or take it all the way down if you need to. So, again, if it was an equal sign, go for it. It's false because 5 does not equal negative 21. But when it's an inequality sign, you got to take it down, cancel those variables. Okay? Any questions on that? Yeah.
The top one,
Mm-hmm.
the false one, yeah. Like what I remember, like how you can change that though is that you canceled the 14x with a negative 14.
Yep. Cancel it with the negative 14x, and then you look at what's left. Good. Okay, so you are going to do page 372, numbers 1 through 31, just the odds. And I also want you to do that number 2. It's a good writing one. Copy the problem on the line. Show all of your steps. And make sure that you, just make sure you understand what you're doing now. Okay?